All right, today we're going to talk about one of my favorite features in any modern programming language, Go's channels. Honestly, they're the secret sauce behind Go's concurrency superpower, how it manages thousands of things happening at once, safely, and believe it or not, simply.
I mean, think about it. This is one of the hardest problems in computer science. The traditional way, you use these complex locks to protect your data, but that whole approach is just littered with traps. Deadlocks, race conditions, it's a nightmare. Go takes a totally different path. It avoids these problems by shifting the focus away from locking data and toward communicating it safely.
Okay, so what is a channel, really? Instead of thinking about complicated locks, just picture a safe pipeline. It's this typed connection that lets Go's super lightweight threads, its Go routines, pass information back and forth, even when they're all running at the exact same time. It's a conduit for communication.
Now, channels come in two main flavors. You've got your unbuffered channel, which is like a direct, synchronized handoff. The sender literally has to wait for the receiver to be ready, kind of like passing a baton in a relay race. Then you have the buffered channel. This one's more like a mailbox. You can drop off a few messages and just walk away as long as there's still space in the box. And this right here is pure synchronization in action. We can kick off a task to run in the background, and our main program doesn't have to guess or poll to see when it's done. That final line, that little arrow pointing out a fig, it just blocks. The program pauses right there until that background task sends its signal. It's clean, it's simple, and it's a foolproof way to wait.
Okay, so now that we've seen the basics, let's see how we can use this simple little building block to solve a really common, real-world problem: managing workload.
So picture this. Your server is getting absolutely flooded with incoming requests. If you just try to process every single one of them at the same time, you're going to run out of memory, or CPU, or both. Your system's going to fall over. You need a way to control the flow, to put a cap on how many things you're handling at once.
And this is where a buffered channel gets really clever. We can use it for rate limiting. By making a channel with a set capacity, let's say 10, we've basically created 10 slots. Before a task can start, it has to send a value to the channel to claim a slot. If all 10 slots are full, well, it has to wait. When it's finished, it reads a value back, freeing up that slot for the next task. It's just like a bouncer at a nightclub, enforcing a strict capacity limit.
But wait, here's the classic gotcha. While we've limited the number of actively processing tasks to 10, we haven't limited the number of waiting tasks. So if a million requests come in, we'd still create a million Go routines, all just sitting there waiting for a slot. We just shifted the bottleneck from our CPU to our memory. Oops.
So this is what programming is all about, right? You find a flaw, you refine your solution. The gating fix is a pretty good improvement. You grab the slot before you even create the Go routine. That stops the memory leak. But the worker pool pattern? That's often the gold standard. You create a fixed number of workers up front, they just pull jobs from a queue and are constantly reused, which is incredibly efficient.
All right, now this is where Go's design really starts to flex its muscles, and things get, well, fascinating. In Go, channels are first-class citizens. That means you can pass them around just like any other value, like an integer or a string. And that means a channel can carry other channels.
Take a very close look at this slide, especially that last field. When a client sends a request, it doesn't just send the data and the function it wants to run. No, it also creates and packs its own private return address, a brand new channel, right inside the request itself.
With that one simple idea, you can create a full, parallel, non-blocking request and response system. The client bundles up its question and its own personal phone line, sends it off, and then just listens on that line for the answer. The server worker doesn't even need to know who the client is. It just does the work and sends the answer back down the specific channel it was given.
And that is the magic. We've built this complex, safe system that can handle tons of clients at once, and we didn't use a single traditional mutex or a lock. All of that complexity just disappears because we focused entirely on organizing the communication between our different tasks.
So, let's zoom out for a second. What's the big overarching idea we should take away from all of this? What's the core philosophy?
This is so much more than just a different syntax. It's a safer and, honestly, a clearer way to build concurrent programs. Instead of trying to protect shared data with locks, you coordinate everything by passing data between tasks. And that single shift in thinking just eliminates entire categories of bugs by design. It lets you build these incredibly complex systems from simple, composable pieces. And that's the real power of Go channels. It's a tool that actively encourages you to structure your code as a series of clear, safe conversations. Thanks for joining this explainer.